Okay, so it's once again the last. What can we don't have interpreters? And it's the last day that's supposed to be here. So from next week there won't be interpreters. If you need someone to interpret what I'm saying, you probably do. You please ask me. I don't mind. No, those aren't interpreters. It's fine. Good. You can sit there. So. Good. Right. So I apologize for the TAT chaos. First week is fine. I don't mind that. But it's a bit disappointing that IT made a tiny mistake. The people who run Narga they've spoken to me. I've spoken to them. They're working with IT to fix it. So I'm hoping that not by next start, but by next week, you'll all be able to log in. But unfortunately, we have to wait. A couple of things. Firstly, class representatives. Who volunteered last time? Did you get my email?
I didn't get it.
Okay, maybe I didn't pick you. I'm sorry. There were five. I had 5 numbers, and I picked randomly. I picked 3. 1, 3, and 5. Justin. Are you there, Justin? Are you Justin?
I didn't sign up to be a program.
What's your surname? Well, and Stephanie, that must be you, and Rivaldo. Did you get my email? You must respond. No, Justin. Justin falls off the list. Who's the Okay. I'm going to guess your name is Craig.
Yes.
Justin 0 for computer science. Okay, I'll send you. So that's class reps. These are your class reps. I'll put the pics on the module framework. Promises. One thing I have fixed, promise to fix and have fixed. I detest the fact that this screen is not struck. I want to touch it, but it's not black. One thing I have fixed is this little button. It should be sending me an email now. Yes. So if I wanted to tell myself something, I can do that. I'll respond to myself and tell myself to mind my own business. Okay, right. Fine. So that button works. I still need to finalize the project, and I want to do it this weekend. If other CAS does not intervene, but it should be working. We've applied for money for mentor groups, but they only come a little bit later, sometimes only after the first assessment. Why are you leaving? Why are you still arriving? The money are usually comes only after the first assessment, so that we can pick out the weaker ones and give them mentors. In the past, we've implemented that as study groups. You're not interpreters either. We've implemented those as study groups where these mentors meet with small groups of students, like 10, and sort them out. So ask them what their issues are and help them go through the work and do the exercises together, all that. But we'll see what we do. I have a couple of hundred little questions, quiz questions. In fact, these are exactly the kind of questions that will be in the tests, all of your tests. So it's a good idea to look at them. And we're going to take quiz 0, which is borderline trivial, to just see how it works. So let's just try it, quiz 0. So I've already done it this morning. I only scored 99 out of 300 or 21, what have you. So I'll try it again. When you learn the quiz, when you do, and the test will be just about the same. There are other kind of questions in the test as well. So monkey puzzles or multiple choice, multiple answer questions, and other kinds. But there will be these programming questions as well. So there will be a little instruction at the top. Find the missing code below that displays the message "Hello World" on the screen or console. And then you'll get a little editor. Unfortunately, because of the screen resolution, it's tiny, but maybe can I resize it? Oh, yeah, there we go. Just tiny little bigger. Right. So you'll get a little box, editor box, where you can write the Java program. This editor is not super smart, but it knows some Java, so it's highlighted keywords. You can see that. And the idea is that there will be these comments, begin and end. And you're supposed to put your answer in the middle. So don't delete begin and end. And we just put an answer here. System.out, print line. Well, let's go for hello, Yaku. Okay? And then you can check your answer. But every time you check, you lose some marks. You won't get full marks if you check and you're wrong. If you check and it's all right, then it's fine. But if I check now, I'll lose 1% if I'm wrong. And if I check a second time, I'll lose another 2%. Maybe 2% in total. And then 4, and then 6, and then 8, and then 10. So you can't just guess to find the right answer. Every time you attempt to answer the question and you're wrong, you lose some marks. So that's to encourage you to think about before you submit your answers and not have people sit in the exams and just guess until they hit upon the right answer. So let's check this little program. I'm not sure, not correct. Semicolon expected. So my problem, that's easy to fix. Here we go. Oh no. Empty command line. That was the input. So nothing in the command line. Expect, but it got hello Yaku. Oh, it's so finicky. Okay, fine. Right. Hello world. I've changed that. I'm going to check again. Ah, excellent. So now it says all tests passed. And these ones are trivial, but if you do make a mistake, and there are inputs for the program, like this. Well, let's try one. I think the next program works like that. This time it says, fill in the missing code below that takes a string from the command line. The program must then display the message, hello, what, on the screen or console, where what is a string given on the command line. You may assume there is at least one command line argument. Okay, fine. We can do that. I'm going to make a string variable that records the command line. Arg0 is first command line parameter, it's a string. I'm putting it inside a variable that I'm declaring called s. And then I'm going to say system.out print line. And I'm going to check. Oh, okay. So it says I have an error. It says the input was Yaku. So somebody ran my program with Yaku on the command line, and it expected to see hello Yaku exclamation mark, just as the question asked, hello Yaku exclamation mark. But instead it just saw Yaku. And that's because I just printed S. I didn't print the hello string in front. So I'm going to print that. Exclamation at the end. I'm using the plus operator to concatenate the strings. I'm going to check again. Oh, it's complaining again. It expected hello, comma, space, Yaku, and it didn't see the space. So it's quite finicky. But then some people are like that. They're very fussy. So if you write software that operates a lung machine in the hospital, many of those patients are expected to work all the time, exactly as prescribed. Or if you write flight software, some of those pilots expect the plane to land on the right runway every single time. And they don't like it when you don't leave any space between it and the plane in front. So computers can be finicky like this. Very important to read properly and excellent. Okie dokie. So there's one more question. I'm not going to answer that. I probably won't get a good score again. And then I'll finish. So in a quiz situation, in a test situation, you be doing all this. You'd say, finish. I've answered all the questions I'm going to answer. And submit all and finish. And then I'll ask you again, do you want to submit all? Yes, I'm done, done, done. In this case, in this scenario, because these are quizzes that I want you to learn from, it will actually give you a report afterwards. So it will tell you, on question 1, this was the question, that's your answer, and it was perfectly all right. And here is the official solution. And here is your score. And here is question 2, and question, your answer, your result, the official solution. It didn't use a string variable, but that's fine. And there's your score, and then that's the third question, and that's the result because we didn't fill in answer. And here's the official answer. So these quiz situations will give you all the official answers. If you want to cheat on the quizzes, you can have a friend do all the questions, and then you can check what the answers are, and you can fill them in yourself, which would be really idiotic because these don't count for marks. These quizzes don't count for any marks. They're simply there to help you practice. So I think the right solution is to do them on your own or with a partner. It's a good idea to have a buddy, study together, talk about the work, help each other. And then, even if you got it wrong or right, look at the answers. Don't write them down or don't memorize them, but try to understand them and reattempt the quiz. I think you can reattempt as many times as you want. Okay, right. So let's get to the real work that we're supposed to talk about. Let's just check that Google Hangouts is still on. Yes, it is. Excellent. I know it's very annoying on YouTube to see that recursive screen going, but it's very important for me to know that we're still being recorded. So we have to talk about the next section of the work. And I have a very simple mind. So I couldn't study, and I still can't study the new thing without seeing the big picture. So we're going to talk about selection, which is an important new concept if you haven't programmed before. But the big picture, I need to know where we are in the whole scheme of our entire life, or at least of this course. So what we've done until now is talk about primitive data types and assignments, and also declarations, but that's somehow implicit. We looked at a lot of math functions, we've seen those, and you've read about them. And we've done a little bit of text I/O, so we can write strings to the screen, and we can read them from the command line. Next, we're going to look at something called conditionals, that's today, selection, and loops next week. Then later on, we're going to start looking at arrays, and the second, third, and functions and modules. Java is an object-oriented language, but at this moment, we don't know what that means. All of that is covered in 144. In this course, we're not really going to look at objects, even though that's in some sense the core of Java. But we won't be able to avoid it either. So what we've done until now is basically a calculator. Like you did in the TAT yesterday, I hope some of you You can read values, calculate some answer, display it back. But your program can't really do complicated behavior. That's what we need to learn. To get a real computer, we need to be able to do conditionals and loops. In previous years, we taught a bridging course for students who didn't have computer studies at school. And that was 5 days, let's say 4 days of lectures. The 5th day was. And we did everything up to arrays and made it all functions. And I got to know when students lose it. So everybody can manage this. This stuff is pretty easy. If you're having trouble with this, please talk to another else for some real help. Conditionals is fine the first day. Easy to understand and people cope with that. Loops, things go off the rails a little bit, especially if we combine loops and really use it. And it's just too much to take in. And it's fine. You don't have to be get it right the first time, but you have to. You will struggle, some of you. So don't be defeated when. Don't let it defeat you. Let's have another go at it because everybody manages to get it in the end. Right. What is this selection thing? What is this conditional thing? Until now, we've been writing programs that follow a lot of steps. So we've been giving it statement, statement, statement. We only know 3 statements. System out, print line, variable declarations, variable assignments. Those are the only 3 statements we know. And we've been putting them in a list because that's how Java executes programs. It starts with the first statement or instruction and carries it out one by one until it reaches the end. But we want more complex behavior. We want our program to be able to make decisions and behave in different ways. If I gave one kind of command line parameter, I want it to behave in one way. And if I give it a different command line argument, it needs to behave in a different way. So we need to be able to make, that's very exciting. We need to be able to make choices based on Booleans. Checking something, checking if it's true or false, and then having one behavior or another behavior. So we're going to start looking at how to make these diverging paths in our programs. And it's pretty easy. Java has a statement. It's called an if statement. And it's very, very important to know that Java is pretty stupid, especially the Java compiler. It cannot discern what you really intend to do in your program. It can only read what you've written. It doesn't know your intent. Also, you need to speak its language. You need to write Java. And Java has a very strict and simple syntax. And you must absolutely stick to that. If you can do this in common sense stuff, I've program before, you're going to make a mistake. You're going to cry, and someone's going to come along and say, put a semicolon right after the if. That's not what Java. Java if keyword. Ah, man, come on. It's not. There we go. Then an open parentheses. No matter what you write, you have to write the open parentheses. Some Boolean expression. So it can be, or it can be a Boolean value and another value, or it can be not a Boolean value. Some kind of something that will end up being a Boolean. Then a close parentheses. You must write these parentheses. And then I tell all students, you must write an open brace, a new list of statements, and a closing brace. And then we write else, open brace, list of statements, and a closing brace. And what Java will do is, it'll get to this if statement, it'll look at the Boolean expression. If that Boolean expression evaluates as true, value is true, Java will execute all these first statements, all the statements around here. I've just put one, statement C, but you can have many statements. And in fact, we can put ifs inside ifs and all other kinds of stuff. But for now, let's assume that it's just statement T. So we get to the Boolean expression, check if it's true or false. If it's true, Java will do statement T and then jump to the end of the if statement down here. If the Boolean expression is false, Java will do statement, it will execute statement F and jump to the end. So it'll only ever do one of those two blocks, either statement T or statement F. For the single execution of if, it does either the true part or the false part. Sometimes we call this if then else. So if this is true, then do that. Or when we talk about the true body, or if the then body and the else body, statements inside. Of course, if we want, we can put more than one statement, or you can even put 0. Sometimes we don't want anything to happen if a statement is false. So we can just put nothing inside the else block. Or if we want, we can leave out the else block entirely. So in this case, I've written an if statement that says, if x is less than 0, so I have some variable x, it contains maybe an integer, maybe a double, something else maybe. If it is less than 0, then I want this statement to execute. It's an assignment. It says, put inside variable x the value of minus x. So x was 0, sorry, less than 0, negative. Minus x is therefore positive. So I'm putting the positive value inside x. And there's no else. So if x is not less than 0, if it's greater than or equal to 0, this if statement does nothing. Java comes along and sees, is this true or false? Oh, it's false. X is already greater than or equal to 0. So jump to the end of the if statement. Nothing is executed if this is false. And this little piece of code calculates the absolute value of x. Beforehand, if x was negative, then I'll do this assignment and turn it positive. Otherwise, if it was 0 or positive, nothing happens and it stays 0 or positive. Absolute value calculation. What about this? If x is greater than y, then put inside the max variable x, the greater value. Else, if x is less than or equal to y, do this part. Put y inside max. So at the end, max will contain the maximum value between x and y. The maximum of x and y. So I've calculated the max. But in fact, I could have done this in an easier way by just calling math.max. Sometimes you don't, though. Yes? Aha. Is, let's say, 5 greater than 5? Okay, so I'm going to put 5 inside max. What is the maximum of 5 and 5? 5. So max will still contain the maximum. Good question. Java doesn't know what we're doing. I know I've called the variable max, but I could have called it Sam or any other, Alex or any other name. So it just blindly did what I told it to do. If I called this variable min, it wouldn't have made a difference. Java would have still put the maximum value inside min. It doesn't make sense to humans who are going to read the program, which is why we have to choose good variable names. But Java doesn't care. It does what we tell it to do. Land a plane underwater? Sure, I'll do that. There have been weird incidents, especially with planes. So in the 70s, 80s, there was a plane that refused to land in the Netherlands at Schiphol Airport because Schiphol lies under the sea level. The Netherlands has, these systems of dikes where they dam up the sea, and the land level is actually below sea level. The land is lower than the sea. So the airport was lower than the sea, and somewhere in the code for the airplane's navigation, there was an if saying, if the ground level is below sea level, do not land. Do not land below water. And so this plane simply refused to land at Schiphol. I don't know what they did. They went somewhere else. Okay. If statements are powerful. Good. One more. With multiple assignments. Oh, inside the if. If x is greater than y, declare a new variable, okay, t, and put x in t. And then put y in x and t in y. So if this is a swap statement, and at the end of this code, at the end of this if statement, which is the body is only executed if x is greater than y, x is greater than y, always. Sorry, y is greater than x, always. So if y was greater than x to start with, this would have been false, because y is greater than x, and at the end, y is still greater than x. And if y is not greater than x to start with, so x is greater, this code swaps x and y. So once again, at the end, y is greater. What I've done is I've sorted two values. I've sorted them so that the smaller value sits in x and the larger value sits in y. After this code is executed, x is always smaller, y is always greater. Coolio, right. This is an if statement. Very important, we're going to use it all over the place. And there are some examples, but I just want to skip to this slide before I run out of time. What time is it? Oh, I've got loads of time. We can look at those programs in detail. Until now, we've done 4 Java statements. Print line, variable declarations, variable assignments, and now today, an if-else. And we need to do 10 or 20,000 if-elses, and we'll know if-else. We're not going to do that, but in essence, we only have one more, and then we've done all 5 statements. This is not strictly true, because there may be a few more, but they're not as important. With one more statement, with the while statement that we'll do next week, we can really write any program that anyone can write in Java. With just these 5 statements, we have enough ammunition to write any program that anyone can want. It won't be pretty, but we can do it. Okie dokie. Right. Let's go back and check the if statement in action. If statement in its native form, the while. So let's read this little program. It says the class is called flip. I've got public static void main, which I'm always going to have. And then it starts with an if statement immediately. It says if some Boolean, okay, what's a Boolean? Math.random, bracket. Okay, so that's that function that returns a random value between 0 and 1. It can be any value, 0.556, 0.557, 0.192, 74C, 3. We can't predict which value it will return. We shouldn't be able to. If random value 0.5. Okay, so that's what those values lie below 0.5, half of and so that will return below 0.5. So if that happens, my program is going to system out at print line heads, else it's going to output system at print line system out. So basically, this is a coin toss, flipping a coin, as the beautiful picture illustrates. Okay, let's just run this program because I want to do a little experiment. Okay, first off, let's move this here. And second, let's type that program. Flip.java. Whew, that was quick. Right. So there's a program exactly as on the slide. And I want to check if it works. How am I going to check if it works? Well, it compiles. That's step 1. Okay, I flip the coin once. It gives me tails. Tails. I hope it's not going to print tails all the time. What are the chances that it'll print 2 tails in a row? What do you want?
0.25%.
Okay, 1 in 4. Let's see. Oh, 1 in 8. So it can print heads. How many is that now? 4 tosses, 3 tails. 3 out of 5 tails. 4 out of 6 tails. 4 out of 7 tails. 4 out of 8 tails. Oh, good. That's break even. 4 out of 9 tails. Just one more tails. Oh. 4 out of 10 tails. So 40% of the flips were tails, 60% were heads. Oh, you can't see. I'm so sorry. All you see is heads and tails. Okay, cool. Can't I fix this one as well? Just give me a second. It's dark. Aspect. Right there. I don't want to break this. Ah, I do want to break this. How do I say okay? Okay, I think this has fixed it. It's not fixed at all. Okay, never mind. We'll just live like this. 40% failed, but I'm not too concerned because I'm sure that it's just a normal aberration of statistics. And if I keep on doing this, I'll end up with 50% fails. That's out of 100 or 1,000. Just like we did the other day with the dice roll. I wonder how this works. Math.random. How does Java pick a random number? Well, in computer science, there are many algorithms for picking random numbers. We study them. There's a whole field devoted to them. They're extremely important because they're used for cryptography. When you want to encode a secret message or a secret bank transaction, or you want to send an encoded email, all that stuff. You're a terrorist, you want to send a bomb thread, or you want to encode that, all you. Never mind. Cryptography is really important. It's a big part of the, well, it's essential for online commerce. And random numbers is really important in cryptography. So they study it thoroughly. In the past, we've had languages, not Java, but other languages that have had very weak random number generators. So sometimes they give 50% heads and 50% tails. Is that random? Yeah. Rivaldo? What? No. Who says it's random? If I do 1,000 tosses, 50% heads, 50% tails. Okay? Let me tell you what my 1,000 tosses were. They were, first one was heads, then tails, then heads, then tails, heads, then tails, heads and tails. Random? No. They're just alternating. So even though they were equally divided, 50-50, it wasn't biased toward heads, it wasn't biased towards tails. It's still not random at all. So finding these patterns can be extremely tricky. I mean, that's an easy way to see it. Sometimes we can't spot the pattern, and there is a pattern. So we have to be really careful when we use these things, but we can trust Java because it's based on something that Japanese people invented. We don't have to concern ourselves with the details. I think it uses something that Japanese people invented. After French people. Good. Right. Next little program with an if. Well, you'll notice the conspicuous absence of if in this program. Because we saw it before, we did. I can't. My mind this whole week is just blending together. So much has happened. But we did this on Wednesday, yes? You don't have an a in front of the x squared this time, so it's a little simpler, but never mind that. We pick up b and c from the command line, calculate the discriminant, which sits under the square root sign, calculate d, which I used to call delta for some reason, which is the square root of the discriminant, and then the roots are simply minus b plus d over 2 and minus b minus d over 2. Those are the two roots. And I can print them. And if I do that, everybody's happy. There we go. This is bad that you can't see the program and terminal. You can't see. Clear screen, Java, C, quadratic, Java. Okay, Java, quadratic. Oh, yeah. Run. Okay, now it's bad because you can't, doesn't look very nice, but never mind. Array index at advanced property 0 at line 4. And line 4 is right here. I was trying to access arg0, but I didn't give it an arg0. So it gives me that message. So I must remember to actually give it command line arguments 2 and 3. No, man, I wanted to start with something exciting. There we go. So x squared plus 2x minus 3, the roots are 1 and minus 3. But as you saw, if I put in the wrong kind of roots, the discriminant is negative, then I don't have any roots, and Java simply prints nan, not a number. But that's a little ugly, especially if you don't know computers. Yes?
Is there a way to square number, or do you have to use math.pow?
How did you square numbers before you knew about math.pow?
I just multiplied it by itself.
Oh, busy.
Why isn't there? Why do you have carrot notation?
What?
Carrot notation.
Carrot.
The up.
Well, why doesn't it work? Such a good question.
Because that's a binary operation.
So, sorry, what's your name again?
Paul.
What?
Paul.
Paul. Oh, I thought you said Fawn. Okay. Which is an odd name, but not unheard of. What Fawn is telling, Paul is telling us, I'm just kidding, your name is Paul, I know. Is that many cases you can use this. So, you wrote 2 to the 5, where 5 was a superscript, but on computers, we often write something like this, 2 to the 5, and we get the answer. And why doesn't this work in Java? Well, it uses the carry for other things. So we don't want to confuse people. Some languages do have this notation. Other languages you write star star. I don't think this little program knows that. So in the old days we used to write double star, double multiplication for exponentiation. Sometimes people write 2 to the carry 5. But in Java, we have to write math.pow 2.3. Now, this isn't Java, which is why it's confused by my math.pow. But this little language, I can actually write not that. Okay, I can't write that. I have to write something special. Oh, no, I can. Non-zero, it's just a warning. Fine, so it did calculate it. 2 to the 2.3 to the 5.6 is 64.3. So this little language was fine with that. And in Java, I have to write that lot. But when you're squaring, I would not write math.pow. That's overkill. That's like saying we have to talk, and the other person shows up with a loaded gun. You don't need to bring a gun to every little talk you're having. It's overreacting. So if I had to square d suddenly, I'd say double dd equals d times d. No, I don't want to call it dd. That sounds like d plus d. d squared. I just write d times d. I would not write math.pow. No, kind of makes sense, but we don't always have to make sense. That's perfect sense. Okay, fine. What we really want to do is to use an if statement to make this more palatable. So instead of just printing nan, which not all users might understand, we want to add an if statement to this program so that it can neatly print out no real roots. So I add an if statement that asks, if the discriminant is less than 0.0, I'm simply going to write no real roots. Otherwise, I'm going to calculate the square root, because now I know it exists, and calculate the roots and show them on the screen. So let's do that. I'll just type it quickly. Ching. Okay, right. So same little program, just as on the slides. I'm going to compile it. I'm going to try it. So for values that have root, it still has exactly the same behavior. But when there are no roots, I have run the wrong program. My mistake. Students are traumatized. Okay. For values where there are roots, it still prints the roots. But when there are no roots, it prints no real roots. Everybody really happy? Why not? Okay. This isn't, okay. Let's be honest. Who finds this easy peasy? Easy peasy? Okay. Who finds this okay? Okay. Who finds this slightly complicated? But I'll get used to it. I have a class at 9. I have a meeting with a student at 11 and another one at 12 o'clock. But when the clock strikes 1, I'm going to put on my boogie woogie shoes and upload more quizzes on Sunday. Including, it could, probably won't happen, including quizzes about assignments and quizzes about if statements. And you are going to probably what's it called, skip class, or I don't know, maybe you don't have that on Friday afternoon. But when you get home, you're going to do all those quizzes on it. Because you don't need to have Java installed on your computer, don't need to go to log in. You can do all these quizzes on the website. Okay. Rivaldo, Craig, Stephanie, is that your name? How do people call you? I don't call you Steph. Anybody call you Fanny? Ask me. Remind me if I haven't put up those quizzes. Please send me an email, and you do send me your forms, please. Okay. I need to send you the email. But okay, fine. Right. Afrikaans summary, really quickly. Just relax. Just chill. Don't make any noise because it's rudish. What the hell are you doing, Justin? You've been having a red glare. Oh, it's so red. That's the reddest red I've ever seen. Well, you look like you're on fire, but that's fine. Okay. Afrikaanse opsomming. So ons het vandag gepraat, eerst ons 'n bietjie administrasie gedoen en ek het julle gewys wat die heel belangrikste is dat daar hierdie quizzes vooraan. Wat is die kans vir 'n quiz? Nee, dis raaisel vasvra. Ek moet met vasvra. Op die website is, die webwerf is op Sun. Wat jy doen sonder om in te log op die en ek sal nog opbly jou instellings en toekennings gaan toets en jy moet asseblief dit oefen. Programmeer. If you can already program, you can do these quizzes. I call it quiz in a whiz. Okay? You score super high. Watch out, Jack. So as jy dit programmeer, doen die vasvra vinnig, vasvra in 'n That's right. As jy baie vinnig is verby en dan weet jy dit werk perfek. Andersins is dit baie goeie oefening vir jou om na die vrae te kyk en hulle te antwoord online op Sunday. Okay, maar die heel belangrikste wat ons vandag gepraat het is die iets-stelling. Is 'n ware staat te kyk En as hulle waar is, dan doen ek een tipe gedrag. En as hulle vals is, doen ek heeltemal ander tipe gedrag. So ek kan begin om baie meer interessante gedrag in my programme in te bou. Dit is nie uitvoer doen een berekening soos 'n sakrekenaar nie. Hulle kan nou dit self verskillend gedrag. Wat is jou program kan heeltemal verskillende gedragte hê afhangende van wat die gebruiker op die toevoerlyn sit. Is daar enige vrae in Afrikaans, of Français, of Deutsch, English? Any questions? Everybody happy? Good. Then I'll see you again on Monday.